Hello and welcome back to this video. I guess it's on nodal analysis, but really we're at the point of solving this circuit where it's really more of an algebra problem. And what I want to do in this video is I kind of want to give really an overview of all the linear algebra that you will really need to survive in a circuits class, I guess. Hopefully you've had a little bit of linear algebra, that you've at least seen it before. If you have not ever seen linear algebra, it might be a really good idea to go to the Khan Academy, which if you haven't heard, I know I haven't said that name before in the nodal analysis videos, but KHAN Academy.org is a great resource for learning about all different types of math concepts. And if you've never done any type of linear algebra, it would be a really good idea to go to the Khan Academy and check out their videos and their different offerings on linear algebra because it could really help you out. So what we're going to do, and kind of what the whole big point of linear algebra is, if you've taken a linear algebra class, is to solve this equation. A matrix A times a vector x is going to be equal to some other vector b. That is kind of like the big overarching equation in all of linear algebra. And essentially what it means, if I have a matrix, let's say I've got my A matrix that I define like this. And I'm going to define this as a 3 by 3. I'm going to say this A, B, C, D, E, F, A, B, C, D, E, F, G, H, I. So that's a 3 by 3 matrix. I say it's a 3 by 3 because I have got 3 rows in the matrix and 3 columns. So this is 3 rows by 3 columns. We say that A is a 3 by 3 matrix. And I am multiplying A times an x vector. So an x vector could look like this. X, Y, Z, and then that is going to be equal to a B vector, or a B matrix, I guess. You can think of these. I guess I think of these as vectors. I think it's better to think of them as vectors. But A times X is going to be equal to your B vector. So B vector, and I'm going to call that capital A, capital B, capital C over here. Now the way, hopefully you've seen at least a little bit of how matrix multiplication works, but if I was going to multiply A times this vector X and and that would give me my vector B, I could also represent my vector B if I wanted to just expand this out completely. And AB, all these numbers in A, those are just numbers. That's like 5, that could be 6, that could be 12. These are just a whole bunch of different numbers here. These are typically in X, these are variables or unknowns. These are things that I don't know. And then over here, these are, again, they could be numbers or expressions or variables. But the way that this matrix multiplication works, so I'm taking A, multiplying it by X, and that gives me B, is I take this entry A, multiply it by this entry X, take this entry B, multiplied by this entry Y, and this entry C, multiplied by this entry Z, and that gives me my first entry A in my B vector. So if I write that all out, I get A times X, this capital X, so A times this X, plus B times capital Y, B times capital Y, this constant B right here, plus C times capital Z, plus C times capital Z. That's going to give me this A entry in my B vector. So if I expand that out, it looks like this. Then in the next row, I just do pretty much the same thing, but I do it one row down in my A matrix. Take D times X, that's D times capital X, plus E times capital Y, E times capital Y, plus F times capital Z, F times capital Z. And then I'm going to take G times capital X to get my third row, G times capital X plus H times capital Y, H times capital Y, plus I times capital Z. That's I times capital Z. Hopefully this is review for you. Hopefully you have seen this before. And that's also my B vector. I've just expanded out my B vector like this. Hopefully you have seen this before. If you have not seen this before, though, it would be a really, really, really good idea to watch at least a couple of videos just right at the beginning of the Khan Academy playlist on linear algebra. They will really help you out. Just videos on simple matrix multiplication and just simple linear algebra concepts. So if I expand this all out, this is what I get. And these are, typically x, y, and z are unknowns. A, B, C, D, E, F, G, H, I, those are all constants. So I get this. Now, imagine that I kind of rewrote this, or imagine, let's actually, before we do that, let's go back to this expression, AX equal B. And imagine that this was just algebra 1. I just tell you AX equals B. I know what A is, and I know what B is. How do I figure, but I don't know what X is. How would I figure out what X would be? And maybe you would say, well, I divide both sides by capital A. If I divide both sides by capital A, that would tell me what my X vector is. So I would take my B vector, divide by capital A, and that would tell me what X is. Now, it's kind of, we don't really talk about, or we don't really do too often matrix division. But what we can also do, and what we might think of, and you can also, this would actually work in like an Algebra 1 class, instead of multiplying instead of dividing both sides by capital A, we can actually multiply capital A times this quantity that we call its inverse, or times, it's not really in Algebra 1 it's a quantity, in linear algebra it's actually going to be a matrix. We would multiply our matrix capital A times its inverse. And in linear algebra you find out that any matrix that is invertible, A, if you multiply A inverse times A, you get this matrix called the identity, which is kind of like multiplying by 1. So if I multiply by A inverse on this side, I also have to multiply by A inverse on this side. Notice one of the things, I have to actually multiply A inverse times B. I cannot put A inverse on this side. This is not the same thing. B times A inverse is not equivalent to A inverse times B. It's important to make that distinction. I have to multiply A inverse on the left side of B, not on the right side, at least if I do it this way. But in linear algebra, if you multiply A inverse times A, so long as A does have an inverse, you get this quantity called the identity matrix. And essentially, for our purposes right now, you can think of the identity matrix as just multiplying by 1. So our X vector, we can, if we're able to find an inverse for A, we can just say that our X vector is equal to A inverse times our vector B. Now, how does that help us out? Well, look at these equations that we have for our circuit, for our I1, V0, V3, and we've got them equal to these different constants. And then look at this result up here. What if we were to put these equations into matrix form, like this? And what if I told you that it was really, really, really easy for like a computer or your calculator to figure out what that A inverse was and to multiply it times that B? Then we would just get our answer. We would get our answer in just like a couple of seconds. It would be really easy to do. And fortunately, that's exactly what we're going to do. We're going to put all of this information. Now we've gotten these three different equations. We're going to put it into matrix form, into AX equals B. We're going to invert our A matrix, and we're going to multiply it times our B matrix. So let's just go ahead and do that. Let's put these equations into matrix form. So now if I do that, I want to say that my A matrix is going to be something, and I'm going to call my x vector, I1, V0, V3. This is what my x vector is going to be. Okay, so this is my x vector right here. And when I rewrite these expressions here, I'm going to call my x vector I1, V0, V3. So now I'm going to draw my A matrix, which is again going to be a 3 by 3, but I'm going to just put all this information in here. And so the first entry that goes in is for my first equation, and it's the constant that multiplies I1, right? So if I go back up here, remember I get A times X plus B times Y plus C times Z. So the first thing that I put in is the constant that multiplies my variable I1, my unknown I1. So now I just have one I1, right? So I can just put 1 in there. And next thing I put in is what multiplies my V0. I put in 1/6. 1/6 is what multiplies V0. And then I have to put in what multiplies V3. That's just going to be 1/4. So 1I1 plus 1/6 V0 plus 1/4 V3. That's going to be my first equation. I have to set that equal to a B value. And I'll show you exactly how we're going to do that. Actually, all of these values on this side, this one, and this one, are going to turn into our B vector up here. But I don't want to get ahead of myself. We'll see how we do that in just a sec. So then move on to the next equation. So the next equation, how many I1s do I have? Well, I1 doesn't show up at all in this equation, right? So I have 0 I1. Draw the bare 0. I have 0 I1s in this equation. I have no I1, so I put a 0. And then multiplying V0, I have all of this quantity. I have minus 1/6 minus 1 over 12 minus 1 over 15. And then multiplying V3, I've got 1 over 12. So now if I read this equation off, I would have 0 I1 plus V0 times all of this plus V3 times 1 over 12. And that's what I've got, at least on the left-hand side of this expression. And then the last thing I have to do is I have to just do the same thing for this last equation. Again, I don't have any I1s in this expression, so I have 0 I1s. For V0, I've got these reversed actually. So I want what multiplies V0. So what multiplies V0 here is 1/12. 1/12. And then I want what multiplies V3. What multiplies V3 is minus 1/4 minus 1/12. So then I've got minus 1 over 4 minus 1 over 12. And then I have to set, so then the last thing I have to do is I have to set this equal to my B vector. And the B vector is really easy. I just put in these values. 3.3 divided by 6 plus 3.3 divided by 4. Then the next one is minus 3.3 divided by 6. And then the last one is minus 3.3 divided by 4 minus 1. And that's it. I've described, let me pan down here. If I just take all of this, I have described my 3 equations and 3 unknowns in matrix form. So now, if I have something that's able to solve this really easily, I'll just get my answers. Like if I have a calculator or a computer, and you do have a calculator or a computer that can solve this very easily, you'll just get your answers out from this. So anyway, I guess I'm probably going to stop this video here. And in the next bunch of videos, I'm actually going to go through a bunch of different options for solving this linear algebra problem, this AX equals B, for our unknowns I1, V0, and V3. I'm going to do it with MATLAB. I'm going to do it with a few different calculators too, just so you can see it. One last thing I just want to say. I know that this seems like it's taking me forever to do this problem. This is like my 9th video or something like that. I know it seems like it's taking me absolutely forever. That's because I'm explaining every single individual step. Once you get really good at this, this saves tons and tons and tons and tons of time, particularly on an exam. Particularly on an exam where time can be really valuable. Time can, be the difference between, knowing how to do this and knowing how to do it quickly can be the difference between finishing the exam and getting an A and not finishing the exam and getting a C or a D. So I think it's really important to know how to do this and know how to do it quickly. I know that it's taking me forever, but trust me, once you get good at this, you can do this very, very, very quickly. So anyway, thanks for watching. In the next video, I am probably going to use MATLAB to solve this. And really, you don't have to watch, all of the next videos coming up. Like, I'm going to make a video using MATLAB solving this. I'm going to make a video with a few different calculators solving it. Maybe I'll even make a video where we solve it by hand, which, by the way, unless your teacher requires you, unless your teacher explicitly says no calculators on the exam, there is absolutely no reason why you should be solving something like this by hand on the exam. Absolutely none. No one else in your class, the teacher says, solve this. If your professor is saying, you can use calculators, you can, use an equation solver. If your teacher is saying that, there's no reason you should be solving this by hand. You should absolutely use the tools at your disposal to solve this. So anyway, I'll leave you with that. And in the next bunch of videos, we'll just go through some different options of solving this problem. So thanks for watching, and I'll see you in a future video.